Hi everyone, we're going to find the domain of a composite function f of g of x. Just recall that g of x is your inner function here, your outer function is f. So from part 1 we learned that we find the domain of the inner function. Well, first of all, let me write them down. So for this set we're going to do 4 problems here. We have f of x equals the square root of x, and g of x equals 2x plus 3. I'm going to go through the procedure and then I'm going to show you why it's true. The first thing you do is find the domain of the inner function, and we know for that it's just all real numbers. So the domain of g is all real numbers, or any real number. And the domain of f is x, all real numbers, but x has to be greater than 0. It has to be positive, and this can equal 0 as well. So basically, what you do is you set, since it's all real numbers, you set this all real numbers part 2x plus 3 greater than or equal to 0. So you get 2x is greater than or equal to 3, so x is greater than or equal to 3/2. So the domain of f of g is all real numbers. However, x has to be greater than or equal to 1.5 here. Okay? Now the reason that works is when you compose this, we're going to put the inner function inside of here. And we know the domain of the square root of x is x has to be greater than or equal to 0. So basically, when you plug that in, you get the square root of 2x plus 3. So this quantity here has to be greater than or equal to 0, which is what we did here. So basically, we're trying to do this without composing. Okay, the next one we have is f of x equals x minus 2, and g of x is the square root of 1 minus x. First thing we do, we got to do f of g. So first we do is we look at the inner function, and we set this 1 minus x has to be greater than or equal to 0. So 1 is greater than or equal to x, or x is less than or equal to 1. So the domain of g is all real numbers such that x must be less than or equal to 1. And of course for f, the domain is x is all real numbers. Now, the composite function, therefore, is just going to be f composed with g is just going to be this. So basically, f of g is x such that x is less than or equal to 1. And if I compose this, I'm plugging g inside of here. So basically, I'm putting g inside of this x. So you get square root of 1 minus x minus 2. That's f of g. Alright, so basically, from previous work we've done, that tells you that this is the domain. And the next one we have is f of x equals x squared plus 1, and g of x equals the square root of x minus 1. We want to find the domain of the composite function. So basically, we first find the domain here. So you set this to be greater than or equal to 0. So x must be greater than or equal to 1. Therefore, we have blah, blah, blah. The domain of g is all real numbers, but x has to be greater than or equal to 1. And of course, for f, the domain is all real numbers. Therefore, when you compose it, you're just looking at your g, your inner function, x such that x is greater than or equal to 1. And of course, if we did compose it, we would have square root of x minus 1 squared plus 1. And it's still, even though this is going to cancel out, you still have to consider that when you're doing your domain. All right, and the last one we have is very similar. So we have x squared plus 4, that's your f. And your g is going to be square root of x minus 2. And we set that to greater than or equal to 0, so x has to be greater than or equal to 2. That's your domain for g. This is just like the other one. And f is all real numbers. So the composite function is just going to be f composed with g is going to be all real numbers, but x must be greater than or equal to 2. Okay, the next set we're going to do is, instead of f of g, we're going to do some of these same problems, but we're going to use g of f of f, and g of g. So the steps we took in this video is going to help you with the next set we do. Thank you and have a nice day. Bye-bye.